So let's continue on from where we left off. So talking about rivers, we want to talk about the anatomy of rivers. What makes up a river? Well, we can break it down into some parts. And so here on the right, there's some diagrams that show the headwaters. These are the youngest part of the stream. So it seems a little odd, maybe, that streams are going to grow, what we call headwardly. They're eroding into the high mountains up here. So they're actually growing in this direction. So of course, they can't really grow any farther here because they're entering into some body of water, let's say the ocean here. So we have the headwaters where it's steeper, and then we have this flatter area, and then we end up into going into this body of water, creating a delta. So headwaters, plains, deltas, those are kind of the three kind of parts of the river as we kind of look at the anatomy. And so usually steeper in the headwaters. These are where it starts to flatten out. The riverbed is not as steep, and it becomes a little more what we're going to call meandering, and we'll talk about that also. And then the base level is the lowest level of the stream, and that's where it ends. And it forms a delta because it's bringing material all the way from up here down to the delta, discharging it into the body of water, actually creating some land potentially over time. Okay, so if we're going to look at some of the characteristics, so I mentioned some of these terms, I just want to make sure that you're on the same page, you understand what I'm talking about. So the gradient of a stream we might talk about, and because we're here in good old US of A, what? United States, we'll talk about feet per mile. And so that's how gradients are given. And it basically would tell you how many feet in elevation you would change over 1 mile. So a gradient might be 2 feet. That would mean that over every mile, right, in a distance we would travel 1 mile, the elevation change of the stream would only be 2 feet. That's a pretty gentle gradient. Or we might have a gradient of 500 feet, which would mean that over that same mile, my stream's changing in elevation 500 feet. Now that has something to do with, of course, the velocity, how fast the water is moving in the stream. And so it's just a distance per time, and that velocity can be given in a couple different things. We might do, how fast it's going, and we could do miles per hour, right? It's traveling 10 miles per hour, or we might be doing feet per second or things like that, right? What we see, of course, is that the velocity is higher in the steeper streams where we have a higher gradient, and it's a lower velocity where we have, a very low gradient. And then discharge, remember, is a volume. So it's a length times width times height. So it's given in cubic meters or cubic feet. And it's the amount of water that passes through a given point. And interval of time, we're going to use seconds as that. And we use some of those references in the image is prior where we saw the large discharge volumes for some of those streams. So I'm going to try and draw for you really fast some of the differences that you would see between a young and an old stream. So remember, the young stream is typically the part of the stream that's up in the mountains, right? So it's the carving into the mountain, it's growing what we say headwardly. And so what we see for that is if we were to look at a side view, a cross section of the stream, a profile, right? We would say that we could draw a stream and it would be something like this, where what we would call that a V-shaped stream. And the reason it has this shape is because the steep gradient. There's a lot of energy here. And so that energy is directed more vertical, downward. So it's carving into the rock, or the material here. And it's carving at a fairly fast rate. So it's causing this to be a steep-sided canyon, right? So a high velocity of V shape here. Whereas the older streams are the streams that are farther from the mountains in the plains area. Here the streams do not have this very steep gradient, and so they're more eroding horizontally. So we get a profile that looks more like this, where we would say that the stream, where the water is typically flowing here, is, where's my little blue dot? Okay, right here, there's the water. Over here, here's the water, right? So the profile is showing in our first diagram that it's just the stream channel and that's it. There's nothing else. But over in my old stream, I have a stream channel that's in the middle, but I have this flat area on either side, which we're going to define as the floodplain. And the reason it has that floodplain is because my stream is now eroding more horizontally, side to side, and it's actually cut into this material here and create a floodplain. And of course, when water gets too much for the stream to handle and it floods, it will actually go out into the floodplain and cover that area. Now we can also look at a map view. The other way to distinguish young from old is, in general, our young streams will be fairly straight. It'd be flowing like this if we were looking down from, let's say, our airplane. Whereas in an old stream, we tend to see the river does this. It's called meandering, where it moves back and forth. It meanders. And so just in a map view, we might be able to tell something about the age of my stream, old versus young. And of course, in a side view, a cross-sectional view, we would be able to look at some of the features and determine whether it's a young or old stream. So hopefully we can do that in the future here. All right, let me get out of this and go here. Go away. Okay, so, and here's this kind of same story, right? The gradient in the headwaters is deeper, right? So we have a different profile, very steep, kind of V-shaped. But as we move away from that, we get to the plains area. Here's where we have this meandering going on, okay? Let's see, and then we could do this other thing here. Right, so this is kind of what I've just drawn for you, right? We have the tributaries, the straighter part of the streams, and the high gradient areas, the more meandering in the kind of plains area. And then, of course, we deposit things in the delta area. This is another diagram that's kind of illustrating some of the properties. Higher energy, more material, bigger material. That's what we would expect when we look at the steep part, the higher gradient stuff. And the farther we get from the source, then the more gentle the gradient is, and so the smaller materials that we're moving. So we do move lots of material when we, have a stream, and a lot of times that's why the material or the water looks brown, because it contains a lot of material. And so we can transport material in a variety of ways. One is that the material can actually be dissolved, right? So it's in there, but you can't see it. These are salts and things like that that get dissolved in the water. Most of the stuff you're seeing is either the suspended load, which you see kind of not touching the bottom of the stream. And so it's suspended. It's small enough if the velocity of the stream is high enough to keep it from touching the bottom, so it's suspended in the water column of my river system. That's probably what you're seeing as the muddy color. And then we have the bed load, which is the stuff that is actually bouncing or touching the bottom. It's being rolled or bounced or whatever. So these are the three ways that rivers can move material. They're either dissolved load, suspended load, or the bed load. Right? And then some terms that describe how the bed load is moved. We can bounce it, slide it, that kind of stuff, right? So just to give you an idea, maybe this will be helpful, right? We could see that there's the three areas here. The stuff at the bottom that's actually making contact, bed load. Stuff in the middle of the column that's not touching, that's the suspended load. And then, of course, the stuff we can't see, that would be the dreaded dissolved load. So all of this stuff is being transported, doing some work, right? The stuff that's touching the bottom is definitely impacting the bed and causing some erosion, either carving it down or things like that, or it's impacting the sides of the stream and causing it to erode horizontally. All right, let's see. We don't want to make these videos too long, so let's take a little break and then we'll continue on.